Hello, welcome to Guidance Education channel. We are continuing class 11 chemistry, chapter 2, structure of atom. Under that, we are doing quantum mechanical model of atom. This is part 7 under that. We will see the topic that is discussed. The topic is shape of d orbitals and nodes. Please watch the video completely without skipping so that you understand all points clear. And if you think the video is useful, do like the video, share the video, and also leave your comments in the comment box below. If you have not subscribed my channel, do subscribe it now and also press the bell button so that you get intimated as soon as new videos are posted. Thank you very much. Come, let us see the topic. Now we will discuss shape of d orbitals and nodes. We have already discussed the shape of s and p orbitals and their orientations. If you have not watched that video, click the I button in order to watch that. The azimuthal quantum number for d, that is the value of L, is equal to 2. So there are 5 orientations possible. -2, -1, 0, +1, then +2. There are 5 orientations possible. S orbital is spherical and p orbital is dumbbell shaped, whereas the d orbital has a more complex shape. I have explained this in very simple words so you can understand it easily. These orbitals are named as per their orientations. D orbital, as you know, starts with principal quantum number 3. So, the first D orbital is 3D, then 4D, 5D, and so on. All D orbitals, whether it is 3D, 4D, 5D, etc., all of them have 5 orientations. Orientations are always given with respect to the 3 orthogonal coordinates x, y, and z. We follow the text and take this as x-axis and take this as y-axis. These two can be represented on a piece of paper. The third one, which is the z coordinate, this part projects from the piece of paper and this part projects into the piece of paper and they are mutually perpendicular. That is why we call them orthogonal coordinates. The p orbitals are aligned along these coordinates. So we name them as px, py, and pz. But for d orbital, there are 3 coordinates but 5 orientations. So it is a bit complex. So in order to understand it better, what is done is, any two of these coordinates are considered at a time. Either x and y, or x and z, or y and z. And the orientation and shape of the orbital with reference to those two considered coordinates is discussed. While doing so, we cannot represent that coordinate which is projecting outward from the paper on the piece of paper. So, the coordinates are rotated in such a manner that it can be represented on a piece of paper. So, while representing the coordinates, its location may be slightly different. Never mind, it is only to understand. That's all. Okay, now let us see the first d orbital. Each d orbital has 4 lobes, and in this case, the lobes are arranged in the xy plane. This is one xy plane, and this is the other xy plane. So, this orbital has 2 dumbbell shaped portions. So, the shape of the orbital is called double dumbbell shape. It is named dxy because the lobes are in the xy plane. Let us see the second one. This is the x-axis and here we have shown the z-axis. I have told you the reason why it is so. It is only to understand the location of the lobes, how they are oriented. Here, the lobes are in the xz plane. In this diagram, we have shown the z direction projecting from the paper. Such a projection cannot be shown on a board or on a paper. So to facilitate that only, we are showing it like this. So here also it is double dumbbell shape. These two orbitals look alike, but for the alignment of the lobes. This orbital is called dxz orbital. Now let us see the third one. Here, y and z axis are considered. The four lobes of this orbital, which forms the double dumbbell, is oriented in the yz plane. So this orbital is called dyz orbital. These three orbitals are similar. The difference is only with reference to its orientation. It has the shape of a clover leaf. All the three are double dumbbell shaped. Now we will see the fourth one. Again, xy plane is considered as we considered here, but here the four lobes are aligned along the x-axis and y-axis. So scientists have their own ways of calculation and they have represented this as dx square minus y square. The shape is double dumbbell and or clover leaf shape. Now let us see the fifth one. The fifth orbital is aligned along the z-axis. But in the middle, the shape is different. The electrons move in a different pattern in the center. It can move along this plane or along this plane. This central shape is called donut shape. This central portion alone, that is called donut shape. The first four d orbitals are all double dumbbell shaped, but this fifth one is donut shaped. This shape is called torus in mathematics. Let us see that central portion separately. You should have a three-dimensional visualization of this. It is something like the tube of a tire, something like that. Okay, I hope you understand this. The fifth orbital is called dz square orbital. Okay, I hope it is clear. Now, let me explain one more thing. Why this d orbital is having four such lobes. In order to explain why the d orbital has four lobes, we have to know about the nodes. For 3D, how many radial nodes will be there? Radial nodes is given by the formula n minus L minus 1. So here it becomes 3 minus 2 minus 1. The principal quantum number n is equal to 3. Then minus 2 minus 1 becomes minus 3. So 3 minus 3 becomes 0. So there are no radial nodes. What about angular nodes? Angular nodes is equal to the value of L. L is equal to 2. So there are two angular nodes. Whether it is 3D, 4D or 5D, the value of L is 2. Therefore, each of these d orbitals will have two angular nodes. Since there are two angular nodes, there are two values of the wave function psi. So, the four lobes form two dumbbell, which we call double dumbbell. I hope it is clear. Coming back to radial nodes, the number of radial nodes will be 0 for 3D, but for 4D, there will be one radial node. For 5D, there will be two radial nodes and so on. For example, the number of radial nodes for 4D will be equal to 4 minus 3. That will be equal to 1. As I said earlier, L is equal to 2, so minus 2 minus 1 becomes minus 3. Angular node will be only 2. Angular nodes will be the same. So the total number of nodes for 4D will be 1 radial node plus 2 angular nodes. Such questions are asked for the examination. Do practice it. We have already discussed the radial probability density function curve for 3D orbital in the previous video. So I am not repeating it here again. We have made a comparison there. I hope this video was of great use to you. If you found the video useful, do like the video, share the video with your friends who may also be benefited. And if you are watching without subscribing, do subscribe it now. Subscriptions are quite free. Also press the bell button so that you get intimated as soon as new videos are posted. We will meet in the next video with energy level of these various orbitals. Okay, thank you and bye for the present.